which were first used early in the 17th century, dramatically improved the view of the heavens from Earth. But there was still a problem getting a clear view of the stars.
And that is the atmosphere itself causes twinkling of starlight. The molecules of the air actually interact with the light coming from the star and blur out the image slightly.
The Hubble Space Telescope, in orbit above the atmosphere to get a clearer view of the universe, is a cooperative effort of NASA and the European Space Agency. Named for American astronomer Edwin Hubble and placed in orbit by a shuttle crew on April 25, 1990, the 43-foot-long satellite supports itself with electrical and communication systems and pointing and control equipment, and gathers its scientific data through focusing mirrors and imaging equipment. The process begins with individual observation requests from astronomers all around the world, compiled into an observation plan by the Space Telescope Science Institute at Johns Hopkins University in Baltimore. That plan is sent to the Space Telescope Operations Control Center at the Goddard Space Flight Center, from where it is uplinked to Hubble via the Tracking and Data Relay Satellite System. The telescope's guidance system points the viewing aperture according to the observation plan. Sensors check the satellite for movement 40 times each second, and the spin rates of the gyroscopes are adjusted to keep the telescope pointed precisely at its desired target. This is critical when long exposures are needed, as in the case of very faint objects or those that are very, very far away. The telescope's mirrors focus the incoming light onto electronic detectors, which separate that light into its component colors. The information is recorded on optical discs. Data then downlinked to the operations center is delivered to the Institute within 24 hours for processing and distribution to the scientific community. By studying the data, scientists deduce the temperature, motion, composition, and the age of the object which generated the light. At times, Hubble is turned toward objects in our own stellar neighborhood.
When we had the Mars Pathfinder landing on Mars, we used the Hubble Space Telescope to determine the weather on the surface of Mars day after day as we were getting close, to make sure that it was safe for the Pathfinder to land, that it wasn't going to land in a windstorm. We've looked at weather on the moons of Jupiter and of Jupiter. When Levy-Shoemaker, the comet, went into Jupiter's atmosphere, we were able to use Hubble to track that. So we're actually doing solar system exploration with the Hubble Space Telescope.
Other times, the powerful eye of the Hubble Space Telescope explores areas about which nothing is known. The result, as with the Hubble Deep Field View, can be momentous.
When they got the image back in this very small piece of the sky, about the size of the sky that you would see looking through a straw, so a very, very small piece of the sky, they found 1,500 galaxies, just like the Milky Way, in this very, very tiny piece of the sky. And if you expand that finding over the entire sky all around us, the implications are incredible. They believe there are between 50 and 100 billion galaxies now, some numbers that are just absolutely mind-boggling.
But Hubble's ability to stagger the imagination doesn't come only from what it sees.
We see objects that are about 10 billion light years away, which means that not only we see very deep in the universe, but we see very deep in the past of our universe. We see these objects as they were 10 billion years ago, which is not too many billion years after the Big Bang. So we've been going going back in time further away than we have ever been able to do before.
When used in coordination with telescopes that view other portions of the electromagnetic spectrum, such as X-rays, Hubble has helped answer some long-held astronomical questions, like the source of immense bursts of gamma radiation.
We were able to take the X-ray data from some satellites, steer the Hubble to look in that region of the sky in combination with some ground telescopes, and find out that the gamma ray bursts are actually coming from far outside our galaxy. And what that means is these things that we thought were sort of galactic burps of gamma rays, high-energy X-rays, are actually spectacular events that are second only to the Big Bang itself in the amount of energy that's released.
The success of this third servicing visit will keep Hubble in operation to help answer big questions from astronomers on Earth. and from explorers who've shared Hubble's point of view on the cosmos.
When I look out in space and you look out in deep space, you know, and you see all the stars, I always ask my question, it's kind of the question of the century for me, and that is, you know, how far does that go? And there could be two answers. You know, it could be going out to a certain place and stopping. Then my next question is, well, if it stops, what's on the other side of that? But then if it doesn't stop, if it goes on forever, I'm not sure we as humans can understand what forever is. So tell me what this forever is all about. So to me, that is kind of the ultimate question. And what Hubble allows us to do is look out into these vast distances and try to understand our universe, understand what space is all about.